A weird chunk of your day only works because something is happening hundreds of miles over your head. You check the weather, your phone stays synced, a delivery shows up roughly when the app promised, and none of it feels like space stuff. It feels normal, which is exactly why it's easy to miss. GPS alone is estimated to create about $1 billion a day in US economic benefits, and that's before you get to the rest of the orbital plumbing quietly doing its job like the backstage crew in a Marvel movie. So this isn't really about astronaut spectacle, it's about how space became infrastructure, and what breaks if you forget that. That hidden dependency is bigger than most people realize. A lot of people hear space exploration and picture rocket launches, moonwalks, maybe a billionaire in wraparound sunglasses trying to look profound. But the version that affects your life is usually quieter than that. It's weather warnings that arrive early enough to matter. It's the timing that keeps phone networks from drifting out of sync. It's navigation for trucking, aviation, ride shares, farm equipment. It's flood maps, drought tracking, land use records, smoke monitoring. Not glamorous, very useful. And this isn't some brand new future thing. It's been building for decades, then kind of disappeared into the background because it started working. Landsat has been watching Earth for generations. GPS moved from a specialized navigation tool into basic civic plumbing. By the time smartphones, app-based deliveries, and always-on wireless networks became normal, space systems were already sitting underneath them like an operating system you never see unless it crashes. That matters now because modern life is more tightly wound than it used to be. Supply chains run lean. Weather swings can get expensive fast. Networks need precise timing. Cities, insurers, farmers, and emergency managers all make decisions off shared data streams. So when people ask whether space is worth it, the better question is, worth it compared with what? Guessing more, seeing less, reacting later. Even the money story gets framed weirdly. NASA said its FY 2023 activities generated more than $75.6 billion in US economic output. That does not mean every dollar turns into a neat guaranteed profit coupon. It means the spending shows up on Earth through labs, suppliers, universities, contractors, and services people actually use. So if the real value isn't the spectacle, where does it come from? The easiest way to see it is to follow one signal from orbit to your day. Here's how the value actually gets from orbit to everyday life. We can trace the chain through one winter storm decision using NOAA, weather satellites, GPS timing, and a well-documented pattern. Satellites measure things globally. Public agencies process that raw signal, and ordinary systems on Earth become more useful because the information arrives in time. Tom is a warehouse manager in Chicago. As a winter storm starts forming, satellites pick up temperature, moisture, cloud structure, and wind data over huge areas that ground stations can't watch continuously. NOAA feeds that data into numerical weather models. The forecast sharpens, and his routing software shifts from maybe bad tonight to ice corridor here, safer window there. Because that change shows up early enough, he moves a set of departures forward, delays another load, and keeps drivers off the worst stretch before a pileup turns a normal night into chaos. Could ground sensors do all of that alone? Only partly. They're valuable, but they don't give you the same continuous global view, and they definitely don't replace precise timing from orbit. Here is where it clicks. Space doesn't create value just by putting hardware above Earth. It creates value when those measurements get turned into forecasts, maps, timing standards, and other services people can actually use. Space doesn't stop storms. It makes storms legible in time to act. One concrete proof of that hidden layer: GPS isn't just for blue dot navigation. Its timing signal helps keep wireless base stations synchronized, which is one reason GPS is estimated to generate about $1 billion a day in US economic benefits. And the same logic shows up in exploration R&D too. In the 1990s, JPL's push to miniaturize cameras for spacecraft helped advance CMOS image sensors that later spread into digital cameras and phones. Once you see that orbit-to-decision chain, the ripple effects are hard to unsee. Start with weather. When satellite-fed forecasts get better, airports don't just know more. They change plans. Airlines reroute earlier, utilities stage repair crews before ice hits. Emergency managers decide sooner where to open shelters and where not to waste resources. For regular people, that often means fewer nasty surprises, less time stuck, and a better shot at avoiding the expensive kind of bad timing. Same with GPS, and not just the blue dot part. The earlier point about timing turns into a very practical consequence: more reliable wireless service and tighter logistics. When networks stay synchronized and fleets route more precisely, you burn less fuel, lose fewer hours to delays, and deal with less friction in everything from commuting to package delivery. In other words, fewer tiny failures that somehow always happen when you're already late. Funny how that works. Then there's the long view stuff. Landsat has recorded Earth's surface continuously since 1972, which matters because one image shows a snapshot, but decades of images show change. That lets people see flood patterns, drought creep, crop stress, shoreline loss, wildfire damage. The slow motion stuff that's easy to miss until it becomes a bill. USGS estimated the value of Landsat imagery accessed in 2023 at $25.63 billion. That's estimated user value, not revenue. But it tells you the data is doing real work. And the behavior shift is the key. Farmers can adjust irrigation sooner. Insurers and planners can map risk more realistically. Disaster teams can compare before and after imagery to target response faster. NASA's near real-time Landsat system can even deliver some air quality observations within about 3 hours, which helps agencies track smoke and pollution while it's still actionable. The atmosphere refuses to send invoices, which is annoying, but satellites can still keep it honest. So why does this still get dismissed as waste? The strongest version of that criticism is fair on the surface. Rockets are expensive, some missions are flashy, and not every space project turns into a clean consumer payoff you can point to in your kitchen drawer. On the other side, space advocates sometimes make it worse by overselling folklore spin-offs, like NASA personally invented half your house. Both shortcuts blur the real picture. Quick callback: the useful part is often the boring part. A clearer framing is that most space spending isn't money launched into a void. It's money paid on Earth to engineers, suppliers, labs, software teams, universities, tracking networks, and long-lived data systems. NASA's FY 2023 activities were modeled to generate more than $75.6 billion in U.S. economic output. That is not a magic every dollar returns X promise. It is evidence that the spending circulates through the real economy while building capabilities people and businesses use. And here's the part markets often won't fully fund on their own: shared infrastructure with delayed, spread-out benefits. Weather data, Earth observation, orbital safety, timing standards. Everybody uses them, but no single company has much reason to build the whole backbone alone. That's why OECD talks about space sustainability as a public interest issue, not just a business niche. Which gets to the sharper question: not whether space is glamorous, but whether modern life can really function without its invisible scaffolding. Space exploration matters because it quietly builds the systems that make life on Earth safer, smoother, and less guesswork-driven. Now you can spot the hidden infrastructure instead of just the spectacle. So tell me in the comments, what surprised you more, that weather forecasting, GPS timing, or Earth observation data is doing this much work in your daily life? The boring part of space is the part that pays rent.